Hi, my name is Tanram Kanuri, and this is a course on quantum mechanics. You would have probably guessed it by looking at the screen. Let me say some. Let me give you some information about this course. This course is addressed to all kind of audience. Anyone who just has interest in physics can learn it. Uh, University student can use this material as supplement, or may also use this as a reference. In this course, I'm assuming that people watching this has a good understanding of mathematics and physics that is taught in high school. I'm assuming that you're having a little understanding of calculus and wave mechanics. Well, for instance, if you have a good if you know how to differentiate very simple functions like x squared with respect to x, that's enough. You don't need to have a very in-depth understanding of calculus. uh, this course is going to be quite funny and is going to be exciting. I'll try my level best to bring out the joy of learning physics. If you look at the screen, I have written the structure of the course. Before trying to understand this, let me tell you about prerequisites. In prerequisites, there will be around some 10 to 15 videos on prerequisites where we will develop ideas about nature of light, nature of particles like electrons, and then we will learn about wave equation, differentiation, partial differentiation, integration, and other topics essential for learning quantum mechanics. And this is course on quantum mechanics that is non-relativistic and calculus based. If you don't have any idea in linear algebra, then that's not a problem, because we are not going to speak about linear algebra here. It is a calculus based course. Well, let me explain what's on the screen. First we will start, I mean, in this course we are going to learn quantum mechanics. Then we're gonna arrive at Schrodinger equation, both at time independent form and also a steady state form. Time independent form is the equation which contains variable time. In certain situations we don't require such a equation, and the steady state form is one which we desire for some situations because it doesn't contain variable time. And then we will apply what we have learned. We apply Schrodinger equation to a particle in a box, both to a infinite potential well. While we there is no real infinite potential well in real life. That such a well doesn't exist, but we will assume that there is one such thing, and we will apply Schrodinger equation to a infinite potential particle in a infinite potential well. And then we will apply our knowledge to a particle in a finite potential well. Doing doing study of this, we will be going through one of the famous phenomena, that is quantum tunneling, which is one of my favorite and which is so exciting and interesting. And then we will apply Schrodinger equation to an harmonic oscillator, and then to an hydrogen atom, and then to an atom that has many electrons, which is quite complicated than a hydrogen atom. Hydrogen atom is quite simple, it has only one electron. And then if you don't understand what I'm speaking about, if you don't understand what's Schrodinger equation, what is that, we apply that to an infinite potential particle in an infinite potential, and and hydrogen atom applying to that, and all this stuff. You don't need to remember this. In the future we're going to understand what we are speaking about, what I'm speaking about. And again, let me remind you that this is course on quantum mechanics based on calculus and non-relativity. You don't need relativity in here, and you don't need to see what Albert Einstein thought about this, or Albert Einstein doesn't come into this, only except for the except for the photoelectric effect.